Okay. So we're going over homework 9.3a. We're checking our answers first. Let me know if there are any of these that you want me to talk about and go over, and we can talk about.
Oh, yes, sir.
Oh, excuse me.
Wow.
How much longer y'all need? 30 seconds?
I'm done.
Okay. We ready to move on? I have a hard time believing that everybody got 100% of this right. Are there any of these that you want me to talk about?
Yeah, number 6.
Okay.
I mean, I don't understand holes, but all of these are not applicable.
Okay. We're going to have one that has a hole.
Okay.
Or I can make one up that has a hole. Let's talk about number 6, and I can make one up that has a hole in it. All right?
Okay.
Okay. So for number 6, x cubed minus x over 4x squared plus 12x. We got x cubed minus x over, what was it? 4x squared plus 12x. Okay, so what we're trying to do is we are trying to identify vertical asymptotes, horizontal asymptotes, and holes. So just to jog your memory, holes and vertical asymptotes. So holes and vertical asymptotes make the denominator equal to zero. They both come from values of x that make your denominator equal to 0. What makes holes different than vertical asymptotes? Our holes make the numerator 0 as well. And the way that you can check to see where holes come from is if there's a factor, if there's something, if there's a factor that exists on both top and bottom, so then it cancels out. The value of x that makes that 0 is the hole. That's a lot of words.
Yeah, it was.
It's a lot of words, but sometimes you need a lot of words to describe something that's a little more evident in another problem. So let's say we have this for example. Let's say it is 2x minus 4 over x squared minus 4. Okay, 2x minus 4 over x squared minus 4 equals our some function. Okay, so this is what we're looking at. So if we wanted to find the holes of this, the holes and or vertical asymptotes, you would need to factor the top and bottom. So can somebody help me out? What can I factor out of my numerator here?
2.
Yeah, a GCF of 2. So I've got a 2 that comes out. What's left inside the parentheses?
X minus 2.
X minus 2, because if you divide both those by 2, that's what would be left. X minus 2. All right, Does anyone see what x squared minus 4 factors into?
Nothing.
X minus 2, x plus 2.
Yes, remember, a
Oh,
squared
I
minus
know.
b squared. And if it's something squared minus something else that's squared, you can factor it into, basically you square root each of those and do one, a plus the first one and a minus the second one. So this is going to be, since the square root of x is x, square root of that's 2, it's going to be x plus 2 times x minus 2.
Yeah, I didn't like those.
So now you may be seeing it. Notice if there's a factor that exists on both top and bottom, kind of like we got an x minus 2 here and an x minus 2 here. So then it would cancel out. That still means that there's a hole at whatever would make this equal to 0. So we solve that, x minus 2 equals 0, add 2, we get x equals 2. So we have a hole at x equals 2. Because it made both the numerator and denominator equal to 0. Questions about how we identify that hole? Are y'all good with that? Anything else remaining in the denominator that doesn't get canceled out, those are our vertical asymptotes. So we set x plus 2 equal to 0, solve it, subtract 2, we get x equals negative 2 is our vertical asymptote. For this made up problem I made up down here.
There's a factor that exists on both top and bottom.
Any questions differentiating vertical asymptotes and holes? Okay. So doing our non-made up problem, number 6 up here, got to factor everything. So we've got x times x squared minus 1 up top, which that factors even more into x times x plus 1, x minus 1. On the bottom, I can take out a 4x. Divide each by 4, we get x plus 3. So this is 4x, x plus 3. Hold up. Did it say this one didn't have a hole?
Yeah.
Yeah, it says all of them don't have holes.
All right, that's incorrect for number 6. Let's talk about this for a second. So remember, holes and vertical asymptotes. So is there any factor that is repeated on top and bottom? If you look at this.
No.
There actually is. So 4 and x are not together. Those are separate. Think of 4x as 4 times x plus 3. 4 times x plus 3. This is x times x plus 1 times x minus 1. Is there a repeated factor on top and bottom?
Yeah.
The 2 x's, right? X and x. That is what must that mean?
They cancel.
They would cancel, which means there must be a what in this problem?
A hole.
A hole. Where? At the value of x that makes that factor equal to 0. Well, normally we just set the factor equal to 0, so I'm just going to set it equal to 0, and there's our hole. So we have a hole at x equals 0. We have a hole at x equals 0. Are there any other things in the denominator that we could set equal to 0?
Yeah.
Yes, we sure do. We got this x plus 3. What's that going to make? The vertical asymptote. The stuff that doesn't get canceled out that remains in the denominator is our vertical asymptote. So it's going to be x equals -3, right? So we got a vertical asymptote at x equals -3 and a hole at x equals 0. When Miss Pinson made this key, she just made a mistake there. That's okay. We all make mistakes.
That is completely unacceptable. Mistakes are unacceptable.
All right, Ronan.
You know, I made a mistake on my last test. We all make mistakes, right?
That's right.
Yeah. Does it need to be held against me?
I wouldn't say losing points meaning it's held against you. I still forgive you, but I can't give you the percentage points back for that. Okay,
It
so
wasn't that bad news.
we got a hole at x equals 0, vertical asymptote at x equals -3. Does anyone remember how we get the exact coordinate of the hole?
Plug it into back into like the fraction thingy. The
Yeah,
problem.
plug it back into the fraction after you cancel out the factor that it came from. So what's left in here is x plus 1, x minus 1 over 4, x plus 3. So that's going to be, if you just plug in 0 in for all these, since 0 is what we're plugging in, you get 1 times -1. 1 times -1 over 4 times 4. Sorry, 4 times 3. So that's -1/12. So we have the point x equals 0. So we get the point 0, comma, -1/12. And you can put that in your calculator. I think it's 0.083, -0.083. That is where our hole is. And today I'm gonna show you how to graph these, and all this stuff is gonna come together. All right, I know this is kind of a messy page. What's the only other thing we need to do? We need a horizontal asymptote. How do we figure out what the horizontal asymptote is? Are we gonna use this factored form or our original form?
Original.
Original. We take our highest degree on bottom, highest degree on top. What does it mean when the degree is larger up top than it is on bottom?
There's no. Hold on.
There is no horizontal asymptote. There is no horizontal asymptote. Which is why the key says that there is no horizontal asymptote. And this should say x equals 0 for our hole. And if you wanted to be more precise, you would say 0, comma, -1/12. All right, that was more time than I wanted to spend on that. Sorry about that, guys, but that was important that we review that because that is massively going to impact our ability to learn this problem for 9.3. Okay, so for 9.3b, I'm going to show you one example problem. And then, so I want you to take notes on this. This is part of what you're going to submit for today. And then I want you to watch the podcast for 9.3b as well. That just shows one more example problem that Ms. Pinson goes through. I want you to take notes on that. And as soon as you finish both of those, you are done with the assignments for today. There is no homework besides watching the 9.3b podcast, taking notes and submitting those. But I'm also going to be looking for the notes that I'm about to go over right now with this, okay? So make sure you're taking notes over this. This is being recorded. And then after you take notes, I also want you to print homework 9.3b and a sheet of graph paper, which if you don't have graph paper, there is a link where you can download a file of graph paper that you'll need for our class on Thursday. We're going to do this homework together on Thursday. Okay. All right. Questions about this before we get started? All right, so we want to find, when we are graphing, we're going to graph this. This is what we're going to do. We want to be able to list the vertical asymptote, the horizontal asymptote, and the holes to be able to graph this function. So first of all, we got to find our vertical asymptote. Does somebody want to volunteer how we find the vertical asymptote?
Factor it and then set it equal to 0.
Exactly. So we want to factor both denominator and numerator so that then it's obvious what's going to go on. Because we know these two, the vertical asymptote and the holes, are going to come from my denominator. I'm going to be analyzing them. If it cancels out, remember, it's a hole. If it doesn't cancel out and it can equal 0, then it's a vertical asymptote. Okay, so what can I take out of negative 4x minus 8?
4.
Okay, we can say 4. I kind of like taking out the negative too. Let's take out the negative also. You don't have to, you'll still get the same answer. So we take a negative 4 out, and then what's left inside there?
X plus 2.
X plus 2. And then numerator, does it factor?
No.
Does not factor. Okay. So can negative 4 ever equal 0? It cannot. We do not worry about a coefficient out front. If there was an x with it, then it wouldn't matter. That would make it x equals 0 as your factor. But the only thing that matters down here is x plus 2. So what do we know about vertical asymptotes versus holes down here? Do we have any holes?
No.
No holes. No holes for this one. Vertical asymptote, though. Where are we going to have a vertical asymptote?
Negative 2.
Yep. So set this factor equal to 0, solve it. X equals negative 2. So we have vertical asymptote at x equals negative 2. All right, horizontal asymptote. Somebody else who hasn't talked yet. Josh Parker. Do you know how to find a horizontal asymptote?
You like look at the exponent, like, right?
Yeah, you analyze the exponent. Josh, what's the exponent of this top, the numerator?
1, right?
1, yep. And for the bottom?
1.
1. Okay, what does that mean? And this is a hard question. You may not remember.
I don't remember.
So remember, there were some exponent rules, or there were some horizontal asymptote rules. You compared your degree. It was either something small over something big. It was something that was the same on top and bottom, or it was big over small. Do y'all remember what each one meant? Josh, you remember any of these?
Oh, no.
All right, when it was something big or something small, somebody help them out.
Equals 0.
Yes, our horizontal asymptote was y equals 0. What about when it was big over small?
There's not one.
Yes, there was none. There was no horizontal asymptote. And then what about when it's something that's the same over something over itself?
Divide the coefficients.
Yes. So horizontal asymptote, y equals, we can call it top coefficient over bottom coefficient.
So in the classroom, I can have a little more.
Top coefficient over bottom coefficient. So that's what we have here. We have the same over same. What is the top coefficient here?
1.
A 1. So I take a 1 and I divide it by
Negative 1.
-4. So it's just y equals -1 over 4. Y equals -1/4. All right, so you guys have not graphed these before, right? We are about to. So we start by putting our horizontal and vertical asymptotes on there. So assuming this is like 1, 2, 3, and so on, we want them as dashed horizontal lines or vertical lines. So a dashed horizontal or vertical line. And here we go. I'm going to put them in blue. So we've got x equals -2. Remember, that's our vertical line here at x equals -2. Can you all see that okay? X equals -2. And then y equals -1/4. Those of you putting that in the calculator, that's -0.25. This right here is -0.25. So that means we would want it to be just below the axis. That wasn't quite far enough. There's about -1/2. So -0.25 would be about right there. So there are our asymptotes. Those are our asymptotes right there. Okay, now we want to plot some points, and we need exact points. We need exact points. So if we had any holes, guys, which we don't, if we had any, we would put them on here as well. So let's make a little XY chart. And notice our X values here. We've got X values at, so this is an X value of -2. For the left version of this, I want to use the X values that are to the left here. So I got -3, sorry, -3, -4, and -5. So I'm going to put -3, -4, and -5 in like that. Okay. For this right X chart, XY chart, I'm going to do the same thing, just go to the right here. So I'm going to use -1, 0, and 1. You see how I picked those? I just picked the 3 that were to the left of my vertical asymptote and 3 that were to the right of my vertical asymptote. So now I am going to share this with you. You guys aren't going to be able to see this. I'm going to have to share this with y'all. Let me actually share. Can y'all see the calculator pulling up or no?
No.
Okay, let me stop the share for a second and share my desktop with you guys. Okay,
I see it now.
now y'all can see it. What? All right. Okay, you're gonna have to watch Miss Pinson's video to see that. My calculator software is not working properly. What you're gonna do is you're gonna enter this into the calculator, just like Miss Pinson shows you. And then it's gonna give you certain values. So it'll give you certain decimal values. So when I plug this in, I'm gonna tell you what those values are. So when we plug in -3, we're going to get should be -7/4. It'll be -1.75 is what you'll get here. -1.75. And then for -4, you're going to get -8/8. It's -1. So -4, -1. And then when you plug in -5, you're gonna get, sorry, I would have a calculator for this. negative 9 over, that would be 12, negative 0.75. So watch the podcast for how to put that in the actual calculator. So when you're so you have those points now, we're going to plot them. So notice how I'm at negative 3, then negative 1.75 is almost a negative 2, but not quite. So it would be about right there. That's negative 3, negative 1.75. About right there. Because negative 1.5 would be there, negative 2 would be here, so about halfway in between that is right there. Next, we got negative 4, negative 1. We go negative 1, 2, 3, 4. Sorry, negative 4, negative 1. That's an even value, so it's easy. And then I got negative 5, negative 0.75. Negative 5 is here. 0.75 is between like the 1/2 point and the whole value, so about right there. And then when you guys are graphing it, you can see the graph too, and you'll see that it's shaped like this, where it follows the asymptote. So then you would actually plot it and draw the picture. So it goes down like that and goes this way like that. So there's the left side of our graph. Then we would do the same thing for the right side by plugging in these values into the table. And you can also just manually plug them in, but there's an easier way. Watch the podcast and you'll see how that works when you can see the calculator. Okay, so we're gonna do the same thing. We're plugging in negative 1 in for those right there and 0 and 1. So we will get, let me think, negative 5 over negative 4, so that'd be 1.25 for that one. Plug in 0, and you'll get let me think. 0 would be negative 4, negative 8, so 1/2, so 0.5. Plug in 1, you'll get 0.25. So those are our 3 values that we're going to plug in there. So we do the same thing that we did before. So we go to negative 1, 1.25. So negative 1, 1 1/4. So 1 1/2 would be there. 1 would be there. 1 1/4 is about right there. Doesn't have to be perfect, but it shouldn't be like up here close to there. It's got to be somewhere just above that one line, but not quite to 1/2. 0.5, so 0, 1/2. 1/2 is the halfway point right there. And then we've got 1.25. So 1/2 is there, 0, so about right there. And those are my 3 points I'm going to use as my model over here. On the graph in your function, you're going to see that it looks like this. I'm going to change color so that you guys can see it. So in green, going up like that, passing through these points, and then not crossing my asymptote there. We're just getting close to it, but not crossing. And there we go. And that is your preview for this. I want to see these notes in what you submit, as well as Ms. Pinson does one more problem. And that's all you got to do for homework, guys. Okay? So watch that podcast. Check it out. Also, remember to print homework 9.3b as well as a sheet of graph paper. All right. Questions? Anybody have any question about any of this? Okay. Y'all are free to go. Y'all have a great day. I'll be hanging out here if anybody has any questions.